Hello students, welcome to DEY'S Learning. In this video, we are going to discuss two very important parameters to express the concentration of solutions. The parameters are number one, molarity, and number two is molality. So in this video, we will discuss firstly the definition of the two parameters. Secondly, we will point out the differences between the two parameters. And lastly, we will derive the relationship between molarity and molality, right? So let's start the video. Our first topic is molarity. So follow the diagram over here. Look, there is a solution where the volume of the solution is 1 liter or 1000 ml. Okay. So if 1 mole of solute is added to this 1 liter of the solution, the concentration of the solution will be 1 molar. If 1 mole of solute is added to this 1 liter or 1000 ml solution, the concentration of the solution will be 1 molar. So this molarity is normally represented as capital M. M represents molarity. Okay. So it is a 1 molar solution, right? And of course, if X mole of solute is added to this 1 liter of the solution, the concentration of the solution will be X molar, right? मतलब 1 लीटर सॉल्यूशन में जितना मोल सॉल्यूट रहेगा ये सॉल्यूशन के कंसंट्रेशन उतना मोलर हो जाएगा, ठीक है ना? Now we will estimate molarity of a solution quantitatively, right? So now let us consider a solution where W2 gram of a solute is present in V liter of the solution and the molecular mass of the solute is M2, right? So one important thing you have to keep in mind from here, look, this here W2, here the mass of the solute is represented by the W2 and the molecular mass of the solute is represented by M2. Look, it is general convention, not a mandatory fact definitely. For a normal binary solution means a solution where two components are present, one is solute and other is solvent. So for a binary solution, one represents solvent. 1 stands for solvent and 2 represents solute. It is a normal convention which is followed in all standard books. Okay, so here 2 M2 means this is the molecular mass of the solute, and if it would be M1, it would be the molecular mass of the solvent. If it would be W1, then it would be the mass of the solvent. Okay. So here W2 and M2 represents the mass of the solute and the molecular mass of the solute, right? So molarity of the solution will be equal to the number of mole of solute. This is W2 by M2. W2 is the mass of the solute, M2 is the molecular mass of the solute. So this is the number of moles of solute divided by volume per liter. Okay. So this one equal to nothing but W2 divided by M2 into V. So this is the general expression of molarity of a solution, right? This is molarity. So molarity equal to W2 divided by M2 into V. So molarity equal to W2 divided by M2 into V. So what is molarity? So molarity is actually number of moles of solute present per liter of the solution. So we can write, molarity equal to number of moles of solute divided by volume of the solution. volume of the solution in liter. Okay, so this is the expression of molarity. So molarity equal to, I can write here, molarity equal to W2 divided by M2 into V. This is molarity, right? Okay. Okay. Now let us take some simple examples. Okay. Now our first example is 1 molar H2SO4 solution. Of course, 1 molar H2SO4 solution means 1 liter of the solution, 1 liter solution contains definitely 98 gram of H2SO4. Okay. So molarity is actually molar concentration. This is the number of moles of sulfuric acid. This is 1 mole. Number of moles of solute present per liter of the solution. So sometimes molarity is called molar concentration. Okay, number of moles divided by volume of the solution in liter. Okay, our second example is 1 molar urea solution. Urea means, of course, CONH2 whole twice. CONH2 whole twice. This is urea solution. So 1 molar urea solution means, of course, 1 liter of the solution, 1 liter of the solution contains how much? Definitely molecular mass amount of urea. The molecular mass of urea is 60. Okay, so 60 gram urea, right? Carbon is 12, oxygen 16, nitrogen 14, hydrogen is 1. So this is 14, 16 into 2, this is 32 plus 12, this is 44 plus 16 equal to 60, right? So this is, so 1 molar urea means 1 liter of the solution contains 60 gram urea, right? Or example number 3, say 9 gram glucose. This is C6H12O6 is present in say 250 ml of a solution. 250 ml of a solution, right? So we have to calculate the molarity of the solution. Okay. So here 9 gram glucose means 9 gram glucose means 9 divided by molecular mass of glucose is 180. So this is 1 by 20. 1 by 20, this is equal to 0.05. 0.05 moles. Okay. And of course the volume of the solution, this one is 250 divided by 1000, this is 1 by 4, this is 0.25, this is 0.25 liter, right? So so the molarity of the solution, will be 0.05 moles, 0.05 moles divided by 0.25. This one is liters. So mole per liter is nothing but molarity. Okay, so this is 0.5 divided by, so this one is 0.05 divided by 0.25, this is 0.2. okay, so this is 0.2 molar. Okay. Okay. So there can be thousands of problem like that. Okay. So this is a very simple. Molarity means simply mole per liter. Okay. Number of moles of solute divided by volume of the solution in liter, right? So let's move to the second concentration term, which is molality. Okay. Our second concentration term is molality, which is represented by small m, right? So let us consider another solution where 1 mole of solute is present in 1000 gram or 1 kg of solvent. Then the concentration of the solution will be 1 molal. Okay, this is molality. If 1 mole of solute is present in 1000 gram or 1 kg of the solvent, then the concentration of the solution will be 1 molal. Okay. Look at the difference between molarity and molality. In case of molarity, it was the total volume of the solution, which is 1 liter. But here, of course, only the mass of the solvent is considered. It is not the total mass of the solution, it is only the mass of the solvent. Okay, if only the mass of the solvent is 1 kg and 1 mole of solute is present in 1 kg of solvent, then the concentration of the solution will be 1 molal, right? And of course, if y mole of solute is present in 1000 gram or 1 kg of the solvent, the concentration of the solution will be y molal, right? मतलब 1000 ग्राम सॉल्वेंट में जितना मोल सॉल्यूट घोलोगे उसका कंसंट्रेशन हो जाएगा उतना मोलाल. ओके, सो दिस इज द मोलालिटी ऑफ द सॉल्यूशन. So now, as we done earlier, we have to quantitatively estimate the molality of the solution, right? So we can write molality equal to molality. This one is equal to number of moles of solute, divided by mass of the solvent, in kg, in kilogram. Okay. So number of moles of solute present in 1 kg of the solvent is known as the molality of the solution. Let us consider a solution in which W2 gram of solute is dissolved in say W1 gram of say solvent, and of course the molecular mass of the solute is say M2. Okay, then what will be the molality of the solution? Now molality will be now look, molality equal to this one is W2 divided by M2. This is the number of moles of the solute, and W1 gram is the mass of the solvent. We have to divide it by 1000 to convert it into kg. So this one is kg and this one is mole. So mole per kg, this is molality. So this one gives us 1000 W2 divided by M2 into W1. So this is the expression of molality. So this is the expression of molality which is used very extensively. Okay, you will find the application of molality in colligative properties. So molarity and molality are actually two very important parameters. There are many applications of molarity and molality in different fields, like in pathology, in biochemistry, in pharmaceutical industry. There are many applications of molarity and molality. So now we will point out the differences between molarity and molality, right? So let's go on the screen. So here is the difference between molarity and molality. Look, molarity, look, point number 1 of molarity. It is the number of moles of solute dissolved in 1 liter of the solution. Okay. So this is simply mole per liter of the solution, moles of solute present per liter of the solution. And molality, it is the number of moles of solute dissolved in 1 kg of solvent, right? So it is actually the definition, point number 1. Point number 2, molarity is a mass volume calculation. This is very important. Look, molarity means moles of the solute present per liter of the solution. So this is mass per volume. Okay, so this is a mass volume calculation. But in case of molality, it is the mass of the solute present in a particular mass of the solvent, isn't it? So this is actually a mass calculation. Okay, mass by mass calculation. And third point is molarity is dependent on temperature, as the volume of the solution is involved. Of course, volume is dependent on temperature. Volume changes with the change in temperature. So molarity depends on temperature, but molality, as it is a mass calculation, there is no change in mass with the change in temperature. So molality is independent of temperature. Okay, so these are very important 3 differences between molarity and molality. Okay. Now we will derive the relationship between molarity and molality, right? So let molarity of a solution is capital M, the molecular mass of the solute is M2, and the density of the solution is D gram per ml. Okay, so we have to assume these 3 terms to derive this relationship, right? So now look, the molarity of the solution is M. So molarity of the solution M means we can write 1000 ml of the solution, 1000 ml of the solution contains M mole of solute, right? It is the definition. It is the definition of molarity. Okay, 1000 ml of the solution contains M mole of solute. Okay. Now look, the density of the solution is D gram per ml. So if we multiply D by 1000, we will get the mass of the solution in gram. So we can write 1000 D gram of the solution, 1000 D gram of the solution contains, say, M into M2, this gram of solute. Okay, this is the number of moles of solute. If we multiply this number of moles by the molecular mass of the solute, which is M2, we will get the mass of the solute. Number of moles multiplied by molecular mass of the solute. So this is the mass of the solute. So look, 1000 D gram of the solution contains M into M2, this mass of the solute. Now look, if we subtract that M into M2 from 1000 into D, what we will get? This is the mass of the total solution and this is the mass of the solute. So subtraction yields the mass of the solvent, isn't it? So we can write 1000 D minus M into M2. This is the gram of solvent. This is the mass of the solvent contains again M mole of solute. M mole of solute. Okay. We will back to that line. Okay. This is the M mole of solute. This means M into M2 gram of the solute, right? So now we have to calculate. Now we have to calculate 1000 gram of solvent. 1000 gram of solvent contains how much? This is 1000 into M divided by 1000 D minus M into M2. This is the mole of solute. This is the mole of solute. Now recapitulate the definition of molality. Molality is the number of moles of the solute present per 1000 gram of the solvent. This is the molality of the solution, isn't it? So we can write molality of the solution. This is equal to nothing but that 1000 M divided by 1000 D minus M into M2. Okay. So this is the relation between molality and molarity of a solution. There is one popular form of the equation. We can just modify it. Say we can take the reciprocal of this equation. This is 1 by small m molality. This one equal to take the reciprocal of this one. This one will be the numerator. So this is nothing but d by capital M minus this one is M2 divided by 1000. Okay. So this one is nothing but small d by capital M. This one is equal to 1 by M plus 1 by small m plus M2 divided by 1000. Okay. So this is the very popular form. So this is a very common form of the relation between molarity and molality. This equation has many applications. Look at the parameters involved in this equation. This one is molality, this one is molarity, this one is molecular mass, and this one is the density. So there are 1, 2, 3 and 4 parameters. Okay. Say molality of a solution is given in the question and it is asked to calculate the molarity of the solution, then of course the density of the solution must be given in the question paper, and the molecular mass or the solute have to be mentioned definitely. It has been mentioned in the question paper, and molarity of the solution can be calculated if molality, density and the molecular mass or the solute has been mentioned in the question paper. So these are very important relations to calculate molality from molarity or molarity from molality. So this is all about today's video. We will meet in the next video. Bye bye for now.